Zone 3 podcast, AHRA. We are with, what is it, Imedco with Mike. It's shielding you guys specialize in. If you would just kind of give us a wrap up of what you're most excited about here at AHRA.
Well, this particular show, we are reinforce the introduction of our new entry system. The shielded device, as you know, the enclosure has to enable patients and technicians to go in and out of the room. And that particular method of opening and shutting a door has been a real nemesis over the last 25 to 30 years because the door is often abused and frankly ignored. So what we've come up with now is a method so that the door system is something that can be monitored almost automatically. So it's like a 24/7 service capability that keeps track of. Most doors are now closed by pneumatic air and a electromagnetic system. So we monitor that air. Our little device will ensure that the pressure in the line is sufficient. If it's not, it'll pick that up immediately and indicate so on a LED type device. And when that's happening, we know that something's going on either with the bladder system, maybe a leak, or a compressor that could be a failure. So that enables us to sort of catch it up front before you get to the point where you got to shut the system down because the door won't close and seal. So the particular feature that we call our SmartSeal does just that. It's a 24/7 monitoring capability of the MRI door on the shielded device, shielded enclosure, and it also includes a redundant compressor. It'll count cycles, and again, like I said, frequently the door is ignored. So when you get to 5, 6, 7,000 cycles, it should be time to do something and look at it a bit closer. So our little device is kind of like an idiot light on your car. It says, hey, come look at me because you've exceeded 75,000 cycles or 7,500 cycles or 5,000 cycles, whatever you set it to based on your environment.
Yeah, so like you said, you get these doors that typically the only time you would call for service is once something's already happened, but it's good to be proactive, right? So
right, it's the only one in the industry right now that looks forward as proactively than having to react and then hopefully get somebody there to figure out what's going on. And again, it's as important as the shield is because an effective shield will allow you to get a magnet to perform at its peak. And if the shield is compromised, the magnet's going to see some issues and cause problems, and it's going to create more or less issues for the radiologist and the tech who don't have an image that's worthwhile to comment upon or to read.
And so you're saying if the shield is compromised, that could be caused from the seal of the door. And so if you're able to monitor that, you can...
Most often it's the shield door that tends to be the portion of the package that is the weakest of the package. But there are other things, and that's why maintenance just in general is so critical. These days, there are many upgraded shields as there are new shields being installed, and the upgraded shields require just as good a performance as a new one would. And you find when you test these older devices that there could be issues with how the seams maybe have held up. 7 to 10 years on a shield is really good life. You get beyond that, you are likely to find compromises that will indeed be something that are causing issues. And some of those compromises require some pretty extensive repairs. So the best thing to do is to stay on top of the performance of the shield by checking it regularly. And that's what a reasonable maintenance program will offer you. And with the understanding as to what the new equipment would be if you're considering an upgrade, knowing that shield package is important because it would help you understand what's really going to be involved when you get to the construction and have to put a new magnet in, because the magnets won't be placed unless the shield is performing at its peak level.
So when it comes to confining the RF waves, it's important because it helps to prevent artifact.
Right, the function of the shield is to keep radio signals out. That's the primary function. So in order to do that, the radio shield, the RF shield has to be a continuous membrane, so to speak. ceiling, floor, all 4 side walls. And it has to be built in such a way where all of the seams, all of the openings, all of the methods are continuous, because otherwise that signal is going to come through the seam. That's why in your home, if you got a basement, you can turn on an FM radio and you can hear the radio, right? So the same thing occurs here. You need a 6-sided box to keep that shield continuous and prevent all of the exterior signals that might interfere. You're talking two-way radios, you're talking television towers, you're talking cell phone towers, you're talking cell phones in some occasion. So all of those particular items need to be protected or kept outside the box, because inside the box you got the magnet doing its own thing using radio signals. So if that particular set of signals is compromised by having outside interference, now you've screwed up the image, because you're going to have more or inconsistent data, and those are going to cause artifacts and a lot of headaches for the people that are trying to get good results when they're scanning patients.
And we know what an RF or zipper artifact looks like, and we typically know what the cause of it is, but we don't always know where to find the leak, and so
right. Right. So in order to determine that, there's a set of instruments that are used by RF technicians to kind of sense in general and in specific areas just what that leakage might be. So they can go around with a sniffer and essentially check if it's a door compromise. That'll show up as a real major blip on the scope. Same way for a window, if the window is no longer properly secured. And often it's not, because as I mentioned, that door has a lot of weight, and it also lives through hundreds and thousands of cycles. So as you bang that thing open and shut over time, there's a tendency for it to kind of loosen what might be all of the connections that are part of the shield. That's why the connection method is so important. You want to make those seals as snug and tight and durable as possible. But the instrument that we would use would enable us to check for the major compromises, and then likewise for the compromises that might be part of a wall seam or a ceiling seam, or maybe something that would have been used to go through the shield for, let's say, an injector or some other device, maybe an oxygen sensor, that was not put through the proper waveguides and that are allowing the signals to come in through the antenna effect of that device connection. So the shield itself can be compromised and yet evaluated rather effectively by the use of the testing methods that are used.
Well, I like that you guys track the integrity of the seal itself, but you also track the frequency of this usage, because it's directly proportional, right? I mean, as far as likelihood of concerns.
It is, and again, we know over time that at a particular level, it's appropriate to start having someone come in and check it out. I mean, there is a monthly or somewhat a quarterly service program that we suggest, but more often than not, it's ignored or not followed either by the imaging department, service or maintenance group, or perhaps the biomed people, who are more concerned often with the equipment performance and not necessarily with the shield performance. So again, that's why that cycle counts in there, so that we can suggest to them that now it's time, okay, to have someone come in, because it's better to find out before than after. Pay me now or pay me later, right? So that's what that's the theory.
Well, we understand the importance of maintaining that shield and making sure that there's no leakage whatsoever. And one of the biggest things that we find that could cause a leakage is, for example, if we have a patient needs to be monitored and they've got hard lines and stuff like that. So have you guys done anything to counteract for that?
Well, the shield capability, I mean, certainly when you get in the room with the high field and you've got a code or something, that's a big deal, right? But that's not something that we can necessarily prevent, other than allowing the patient who might be in critical care, or maybe infants, the neonatal, that have to constantly be connected to meds that are important to us. So what we've designed is a method where I don't know if that particular portion of the video shows it, but it allows the portable anesthesia equipment that might be unique to this individual who is coming down from upstairs to be scanned and maintained on the critical med during the scan. So what they do is they keep the portable anesthesia equipment outside. They run the lines through the door with a mechanism that allows it to pass through the door and yet not be squeezed tight and shut off when the door is closed, and maintained on the patient as he is placed on the table for the scan. So the meds can be continuous, but that is something which prevents a lot of problems where a disconnect of critical meds might be fatal or might be problematic to the individual patient.
Yeah, I mean, it's a bridge I've crossed before. It's a bridge a lot of techs have crossed before. Mike, thank you for your time.
You're welcome. You're welcome. Thanks for the
really
opportunity.
Nice meeting you, and appreciate your time. And Zone 3 podcast, you want to say we're out to the camera? Say it, we're out.
We're out.
I don't know, do my hands.